Hello and welcome back to part 13 of this video game tutorial series, Introduction to Game Dev, using the Godot engine. I'm actually getting some lectures ready, and this is the trial run from it. And I just thought I'd go ahead and share the videos from the trial run instead of just viewing them myself and deleting them because other people might be interested in some of the points here. In the last video, we're getting ready. We got our landscape and our character, getting ready to add a light and use that for a simple example of movement. And in the last video, we started talking about vectors. So we have a sort of idea of what we're coding, the math we're coding. Um, and that started running a little bit long. We talked about what vectors are in the last video, but now we need to kind of take a quick look at the math we'll need to do with the vectors. So I'm going to go over to the notes to run through that really quick. So in the last video, we talked about what vectors are. It's a collection of numbers in a single multi-part value. And that's very generalized from the formal mathematical definition. And if you're serious about game development, eventually you're going to want to take some linear algebra courses and learn about the math that you're doing in detail, all the theories and stuff. But for us just starting off here, we just need to know the basic idea of what it is. We're working with all the numbers, uh, a collection of numbers instead of a single value, but those numbers go together, kind of like location in space, rotation in space, the color of things. There's multiple dimensions involved. So color space, location space, and all those dimensions go together to give us a space that we're working with. And we talk about how we think about it, but we need to do a little bit of math. And the nice thing about that when it comes to coding is we do deal with each dimension individually. So if we needed to say add two vectors, oh, I probably don't want thread that. Let me undo that and switch to a color that's going to show up better on the screen. So if we wanted to say add two vectors, we're doing a three-dimensional game, so I'll do this in three dimensions. So maybe we have the vector 1, -3, 5, which, like we saw last time, instead of thinking about a point that is the point in space, like you would have probably seen in math class, that is one unit in a positive direction, negative uh, -3 in the horizontal direction, and 5 units up. With vectors, we want to think about the path from the origin or from our starting point to that point. So how do we get from the starting point to the spot to the point we're worried about? And we can add them together because then we have a new starting point and maybe head off some other direction. Um, 3 units up, uh, 3 units forward, 5 units over, and 6 more units up. And from our starting point, then we make two movements, so we need to add those together. And it adds component by component. So we take all of our x components and add those together. And 1 plus 3 gives us 4. -3 plus a 5 would give us a 2. And 5 plus 6 gives us 11. So between those two movements, right, that first arrow followed by the first arrow followed by the second arrow, ultimately we did this. So it just adds components by components, gives us a new vector. We also have scalar multiplication. Uh, Probably could have abbreviated that somewhat. So maybe we have some vector where 2 units in the x direction, 4 units in the y direction, and uh, 3 units in the z direction. So that's our starting point. Or on a three-dimensional plane, and I'm just doing the regular math one out of habit. So XYZ plane. Oh, actually, I just drew the one we have in our game engine. So we're 2 units in our x direction. So we come over 2. Then we go up 4. in our vertical direction, the way it's labeled here, our labels are arbitrary. This one up here I drew in the regular math one, so X, Y, and Z is how I was referring to the picture there. So we go 2 units over, 4 units up, and then 3 units forward to some spot in space, and then we have that arrow that starts at the origin and goes to that spot. But maybe we need, in our game, instead of just getting to that spot, we need to get to that spot 4 times quicker. So we can multiply by a scalar value, which is a single number, and that does the same thing, what you would expect it to do. That 4 applies to each one of our dimensions. So our x dimension gets 4 times longer. The y dimension gets 4 times longer. 4 times 4 is 16. And the z dimension gets 4 times longer, so 12. And as far as game development, that's really the 2 types of vector math that we will do most often. We shouldn't have to get to much multiplication. Hopefully we won't. I'll put it down here at the bottom because I can't guarantee it won't show up. So if we have some vector A, B, C, and need to multiply that by another vector, D, E, F, we take the row times the column. Row times column. And if we have a whole bunch of vectors put together into a matrix, we'd need the sum of each one. But for game dev, it's usually going to be a vector times a vector. So row 1 times column 1. I'll color code this. So row 1 times column 1. And then, so whatever A times D would give us would be our first component. Then the second one, row 2 times column 2. I'll write it this way because that's the way I'm writing most of the vectors. Notice that I did have to change that in order to make the into a row instead of a column like I've been drawing the vectors. But I'll go back to drawing it this way, which would be probably not proper for math class, but it'll be fine for here. And then our row 3 times column 3 would give us that. So if we need to multiply vectors, take the row times the column. If you have a whole bunch of vectors and put them into a matrix, you sum values together and that gets complicated. This doesn't show up very often. In years and years and years of game development, I've only encountered that a couple of times, and there was ways that I could have got around it. So it's a little bit easier than what you would see in math class because we're usually dealing with one vector at a time. So we only have one number in our row and one number in our column, as opposed to a large matrix. But for the most part, this is what we're going to do. So we'll take, if we do multiple movements, like in this picture here, we take that first movement, then we take that second movement. Overall, we just add those together, and this is the result of those movements. Or if we just need to scale things up or down, scaling is one of our transform things. That's where the scale value in the transform shows up, the scaling multiplication. And we just take whatever that single number scalar is and scale each one of our dimensions by that number. So that's a common one on speed. So if we need to go in the 2, 4, 3 direction, but maybe we need to do it quicker, we'll scale that up so it looks like we're going in the 8, 16, 12 direction, and then we cover that space a lot quicker than what we would have in the original one. Those are the 2 that show up most often. I can't guarantee that this won't show up, so you might have to do this occasionally, but in game development, unlike in linear algebra class, you don't have a big matrix where you have to worry about summing all the values together when you multiply rows by columns. You just take one of your vectors as a row and one as a column and multiply them together. And when we're doing this in our code, obviously it's one component at a time, so we write out the equation, and uh, this might show up in debugging and stuff. But just to give a basic idea of what's going on, I wanted to cover that vector multiplication. So what vectors are, how we want to think about them, and modifying our basis, because the thing you learned in math class about starting at 0, 0, and then having the horizontal and perfectly vertical, that's not a restriction. It makes things easier, but it's not a restriction. We can start anywhere we want. We can reorient that and change things. And when we think about it, instead of thinking about the point in space, we want to think about the route in space from the starting point to that. So that frame by frame of the game, we get, uh, after each frame, we have a new starting point, a new location and rotation and possibly scale. And we do that over and over and over again. So that's why we want to deal with vectors. And especially when debugging things, if things aren't working right, you might need to check the math that you coded in. Um, when we add and subtract them, it goes component by component. And if we need to do scalar multiplication, each dimension will scale up by that same multiple. So that's a quick pass on vectors. Very rough idea, uh, just to give us an idea of what we're getting ready to code in the next couple videos. So I will see you there, and then we'll be back to our game engine for that part.